years, their behavioral conditions were significantly altered. So he got interest to understand that probably this has to do something with brain function. And although he's a computer man interested in computer neuroscience interaction, he said that one can do some research in this area to see that if I am right or wrong. Well, so he believes that we have to study the effect of nicotine exposure in different kind of populations, like people suffering from hypertension, diabetes, and even traumatic brain injury. And he showed some of the observations before as a poster in previous two meetings. So now in this case, he wanted to understand what is happening in hypertension. Can the situations in the brain will be more adverse? So he used 9 milligram per kilogram subcutaneous nicotine administration for 1 week and showed previously that it opens the blood-brain barrier. And moreover, if the experiments were done at cold or hot environmental temperatures, both were adversely affecting nicotine neurotoxicity. Some of the previous observations from other work showed that indeed nicotine consumption affects the brain function and nervous system in certain areas. Also, the cerebral blood flow is also related with this nicotine administration. This was a crude example of hemotoxin seen in the animal brain that he tried to do that. And you can see that 4 degrees Celsius and even 21 degrees Celsius, there are much more adverse neuron reaction after nicotine exposure than control. Since this is partly funded by some military organizations, and we know that explosion produces carbon nanoparticles, and therefore he studied some injection of carbon nanoparticles as well. And what you can see here, that administration of single wall carbon nanotubes has more adverse damage to the brain at electron microscopy, both at 21 and 4 degrees Celsius. Temperature has significant effect on the brain pathology under nicotine neurotoxicity. This is a cartoon taken from other places, and it shows clearly that nicotine smoking can produce free radicals, and then it can also induce many kind of tau pathology and also even promote amyloid protein processing. So it is harmful in many ways and affecting neuron, glial cells. So what you would like to do that try to understand the role of hypertension and nicotine administration. And here, this is one kidney, one clip method was used, renal hypertension, and the animals were made hypertensive, and their mean arterial blood pressure was 174, never exceed 180 or 200, and none of them have showing any symptoms. So when they measured blood-brain barrier to advanced flu, as you can see here, that these are chronic hypertension. There is no great difference between saline and chronic hypertension, but when the nicotine was administered, there was significant exacerbation of advanced flu, and also the radioiodine. The brain edema formation was much more higher, and also the cell injuries. Then to understand the mechanisms of oxidative stress, at the moment, he wanted to see neuronal nitric oxide synthase exposure. And as you can see here, that nicotine expressed these NOS positive neurons, but here, when it is in hypertensive, there are much more, and even the neuropil was much more stained to these nitric oxide synthase. It is difficult to understand that whether these are glial cells or microglia that can express more nitric oxide synthase. It requires additional investigation. Summary is shown here, but the more interesting point is that the cerebellum has shown significant increase of nitric oxide synthase. We still do not know its possible mechanisms. These are only findings. So, but we can say that there is massive increase of neural nitric oxide synthase in nicotine neurotoxicity even in hypertensive cases. And this suggests that probably oxidative stress plays an important role. And we need to see, for example, according to his point of view, that oxidative stress may be one of the key factors. And now it could be interesting to see that whether withdrawal of nicotine, because many people can quit smoking, whether there is any progress, natural regeneration or natural repair mechanisms. This he would like to study in another 1 year, maybe next year he can present something. And I stop here. I am from Uppsala University and hope to hear your advice. I will tell you. Thank you very much.
We'll take any questions. Third question. So I know that these are still ongoing studies, but what would you expect about quit smoking? Would that recovery like the brain damage that has really caused?
We feel that if a person quits smoking and don't use it again, routine exposure, maybe the time is more important. Maybe 6 months or 1 year, we have to study that whether the brain is recovering or not. But probably there is a chance that it could recover.